So, good morning, everyone. First of all, let me thank the organization for having me giving a talk at the conference for the third straight year. It's been an honor and a pleasure to speak at this event. I also want to thank everyone who got out of bed in the morning to listen to someone talk about Git and operations all in the same talk. So, bear with me for the next 30 minutes. And last but not least, I would like to thank my employer, Define Crowd, for giving me the opportunity to actually um, being able to deliver some of my knowledge. So what we have on the menu for today. So today we're going to talk a little bit about GitOps. So the idea for this talk is just to have an understanding of what the GitOps principles are, like having a 10,000 foot view of what GitOps is, what it can do for us, so what type of improvements GitOps can bring to the table. We're going to focus a little bit on the delivery part of the GitOps philosophy. We're going to do a quick demo of one of those software agents that actually gets code into a Kubernetes cluster, and we're going to see if there's sometimes some extras. It's just some usually asked questions about GitOps. So without further ado, let's just dive into it. And I would like to start by telling a short story. So we've all been working in operations or development, but someday the sun is I'm sorry, the sun is shining, life is good, and we decide to make a change. So that change, there's the possibility of some system wipeout. So something can go wrong and we have a loss of some part of our system. So my colleague Joe just wants to make sure and take a look that whatever I'm doing is not going to break everything. He takes a look, everything seems okay, and we click enter or trigger a pipeline, and chaos ensues. So like I tell Joe, so remember Joe, that Kubernetes cluster, it's gone. And we've all been at this point, right? We've all been at the point where something failed and everything is fine, but we have to figure out what the hell is going on. So we start to dig into the issue and try to bring everything back. And then comes the second part. Thankfully, we have everything in Terraform, so it's just a matter of running Terraform and the cluster is relaunched. Everything is cool. So the cluster is up, and now we need to figure out what needs to be there, what services need to be run, what kind of integration is there. But fortunately, we have a pipeline for everything. We start to activate the pipelines, and then more trouble comes in. So there was a pipeline that was deactivated, but the service was running. So what the hell was with that? We need to ask the team, why was the pipeline deactivated? What's wrong with the service? Can we not deploy the pipeline? What's wrong? Also, there was a pipeline for a service that was running, but the pipeline fails. Why? We have no idea. Now we have to ask the team. Oh, and Joe remembers there were some manual changes that were there, and the pipeline was triggered from a feature branch. So the headache continues. So we could improve on this. How could this be better? So one of the things that we could do to make this be better is to have a declarative infrastructure. So the main difference here between a declarative infrastructure and an imperative infrastructure is that we declare state instead of declaring actions. So in an imperative formula, what we do is we say, I want this server up, we want this service running, put this file at this location, restart this service every time this file changes. By using a declarative infrastructure, we basically tell state, we say we want a server with these services running, these files at these locations, and so on and so forth. And then some kind of software looks at that configuration and actually knows what to do. Another thing that we could do to actually improve the situation is to have everything in version control. And when I mean everything, I really mean everything, or at least as much as possible. So I mean code, I mean configuration, I mean monitoring rules, dashboards, network policies, whatever you can put in code, you should put in code and put in a version control system. Git, Mercurial, whatever is your choice for version control. With that in mind, changes can be rolled out from version control. So our repository of code will be our source of truth. So we'll start to use already known tools like Git and use code reviews and all those practices that we already use for other things, and everything is rolled out from that source of truth. So one important point that I want to make here, config is code. So if code must be versioned, config also must be versioned. If you have read the SRE book from Google, they actually treat config as the same way that they treat code, and they actually go into the process of building configuration, doing some tests, versioning it, and then there are versions of code that go along with versions of config. And of course, what can be described can be automated. So if I have a declarative infrastructure, so if I have a definition of what my infrastructure should look like, I can actually build some software that can look at that declaration and do something. So Kubernetes is a nice example of that. So we usually tell Kubernetes, I want a deployment with X amount of replicas. That deployment needs to have this configuration, this file at this location, should run this command, and so on and so forth. So in 2017, a company called Weaveworks decided to share with the world something that they had been doing for a while, and they called it GitOps. So I here have a transcript of a blog post that they published, and what they what they meant about GitOps. So their idea was to use Git as their source of truth. So like we've seen previously, the idea is to get everything that we have, all the configuration into Git, and operate everything on their infrastructure from that source code repository. So in their example, they're using version control so that, of course, Git. So they have history, they have peer review, they can roll back and roll forward, and they don't need to poke around with tools, for example, kubectl in the cluster, because everything comes from the repository. So what could they do with that? They could provision their AWS resources and their Kubernetes deployments. All their state was described in one single spot, which was their Git repository. All changes were made by a pull request, with everything done with code reviews, merges, then builds and release pipelines. They would have diff tools that would actually look at the state of their infrastructure and looking at Git and notifying if anything was out of sync, and they actually could go the extra mile of actually putting those tools to actually sync it. And of course, they would have rollbacks and audit logs that would be provided by Git. With this in mind, what are the main principles that GitOps defends? So the entire system is described the declarative. Kubernetes is just one example of many modern cloud native tools that are declarative. So like we've said before, declarative means that we don't say actions to be done, we say state, and that our infrastructure is guaranteed by a set of facts. So everything is in Git, something looks at that Git and knows what to do. And very important is that when we have some disaster, like in the example that we've seen previously, all of our infrastructure, we just need some sort of software that looks at that definition and syncs it and puts it back in the way that it's supposed to be. So the canonical state is version in Git. So GitOps, of course, by the name is using Git, but you can extrapolate this this kind of philosophy to some other version control system if you prefer to use it. And this, of course, trivializes stuff like rollbacks. We just can do a git revert or a git rollback to actually go back and forth and between states. We can use Git's security guarantees like signing commits and having the history of all the author of the changes. So we start to use Git, some of Git's functionalities to our own benefit. Again, approved changes can be applied to the system. So once we have all the state in Git, we can have tools that diff what is already live and what is in Git and can alert us and go the extra mile of actually doing that sync and putting everything back into place. And that's where those software agents come in, and they will actually put everything back into place. And of course, we'll take the human error out of the equation. So what can actually GitOps do for us? So we have here a few points of what GitOps can improve on our pipelines in our daily life. So one of the things that that people usually gain by using something like GitOps is that they have the some increase in productivity. So continuous deployment automation with an integrated feedback usually speeds up the mean time to deployment. So your teams usually can improve the amount of deploys that they can do for every day. So another thing is enhance developer experience. So the idea is to use familiar tools like Git to actually manage updates and features that go back into a Kubernetes cluster. And of course, the onboarding of new developers can be a lot easier because now they're already using tools that they already know, and the and they don't need to know the intricacies of the system that it's underneath. For example, Kubernetes, they just need to know some basics, and then it's just a matter of doing a pull request, a review, and that those changes get reflected on a live system. Another benefit is the improved stability. So when we use Git workflows to actually manage our clusters, we automatically gain a convenient audit log of all of our cluster changes, but that audit log lives outside of our clusters. So those audit logs can be used to meet some compliance requirements like SOC 2 or PCI compliance. Another added benefit is the higher reliability. With Git, we can revert our rollback a change, we can do a fork, and we have reproducible rollbacks. So we have a state that's actually reproducible on our cluster. So everything is described in Git, and in the case of a meltdown, our mean time to recover, it's much faster. Another benefit is the fact that we are now consistent and standard. So if we all use a GitOps model for our infrastructure, for our application, for our Kubernetes clusters, so everything is everyone is using the same tools and actually using the same workflows all across the company. And that makes it for everything to be consistent and to be standard. And of course, like we've seen previously, we have stronger security guarantees, so we can use Git's cryptography to actually sign commits, to track who did what, and the ability to auto ship and have some gates of, for example, we can have a gate of a merge that goes to production. Only a few people can approve those kinds of changes, so that those changes will only be reflected in a production environment after some approval on a merge. And last but not least, we will have tools that will actually diff what is in Git against what is in the infrastructure. They can give us an alert. It will make compliance easier, and it will make auditing a lot easier. So with this in mind, we'll focus a little bit on some of the GitOps continuous delivery agents. So delivering of software and making it run reliable is one of our jobs and one of our main tasks every day. So we're going to touch briefly on a few that are already on the market, just for us to have some feel of what it's already possible with tools that are out there. So just a quick recap. Those tools will need to be declarative, so we'll have some sort of source code that will be versioned in Git, and that those tools will need to read a declarative description of our infrastructure and act on it. They, of course, will need to be automated, so those tools will look at that declaration and decide what they do without any human intervention. They need to be audible, so we'll have our audit in Git, but we will need a way to actually see what they are doing, so they will need to be audible. Preferable, they will be cloud. They'll be designed for Kubernetes, or at least cloud native, so they will be would have been built with cloud native in mind. And of course, they will need to have out-of-the-box integration. So I don't, if I'm deploying something for a Kubernetes cluster, that tool will need to actually know how to deploy something for a Kubernetes cluster. I don't want to be rewriting at least some common use cases all again. And if possible, they will need to be extensible. So that we all have some quirks in our infrastructure, in our application, that will actually need to actually do that small tweak, and those tools should allow for us to actually put our own stamp on what a deployment, for example, looks like. So let's see a few examples of some of those software agents that are already there. So the first one that I would like to show, it's called Flux. Flux was developed by the company that popularized the GitOps and was the tool that they built to actually diff the configuration that was on a Git repository and whatever it was on a Kubernetes cluster. Flux works with both customize and Helm, so out of the box integration. So Flux can look at a Git repository, see if there are some customizations or Helm charts, and actually apply those into a Kubernetes cluster. Usually, an agent runs inside the cluster, and it will actually do that differentiation. Another very popular project nowadays is Argo. So like Flux, it will do something very similar. It will look at a Git repository, it will look at a Kubernetes cluster, and it would decide on what it needs to do when it needs to sync. Argo, as it's a little bit more complex in terms of the functionalities that is provided, it also has a very nice UI. And just out of curiosity, the Argo team and the Flux team last year had some discussions, and they decided, and they found out, and they decided that they were doing a lot of stuff in common. So there's now a shared repository called the GitOps engine, where they're basically just merging a lot of common functionality, like getting information from a Git repository, doing a deploy with Helm, doing a deploy with Customize. So those are both operations that both projects do. So they decided to create a GitOps core engine where that it's an open source project where they will basically merge all the common code that they were using. And another option is Jenkins X. So Jenkins had, for very good reasons, some bad rep in the past few years, and one of those reasons was the fact that a lot of people said that Jenkins was not built for the cloud native world. So it was not built with cloud native in mind. With that, Jenkins X showed up, and that the whole idea of Jenkins X was exactly to build a tool based on Jenkins that was cloud native. And that's exactly what Jenkins X is. And Jenkins X it's an effort on that sense. It follows the GitOps principles, and it does something very similar like we did previously. It looks at a Git repository, it knows what a Kubernetes cluster is, and it knows how to sync it, how to put everything in place. So underneath all of these tools work a little bit differently. They are quick, some have more features than others, but the main principle is the same. It's software that looks at a Git repository where there's a definition of what our infrastructure should look like, and they will actually sync in a Kubernetes cluster and put everything back into place and send us warnings when something is not okay. So an example of what a GitOps pipeline would look like is something that we are already accustomed to without many changes. So there's some code in Git, there's some change that is merged and approved, a container is built, and it's sent to a container registry. After that is done, some config is done an update. It can be automatic. So for Flux, for example, can look at a container registry and update his own configuration so that it is deployed. It can be a manual change. It can be a script in a pipeline, whatever it is. But the main step is that some configuration is done, and then an agent running inside a cluster will actually look at that config and sync whatever is inside the cluster to reflect what that configuration is. So I'm going to do a very quick demo of Flux. So Flux is a lot simpler, for example, than Argo. There's a talk this afternoon, and they will be showing Argo. So that's why I decided to show a little bit about Flux. So I highly encourage you to actually go into and listen to that talk. You're going to see a lot of cool stuff. But in this example, I'm just going to see how we can get from a Git repository code running in a Kubernetes cluster. So let's dive into it. So I have here a repository. I'm going to make all of this available for everyone. So if you want to try out, so what we are going to do is that we are going to deploy this application. I'll show it in a few seconds. This application, because I'm a lazy I'm a lazy person. I'm using a repository of someone who already has some configuration to get code into a Kubernetes cluster. So this repository is an application that has customizations to get the application into a Kubernetes cluster. And because FluxCD supports customize, has a customized controller, it will make use of that configuration to actually deploy the application. Better? Thank you. So quickly, so this is just a tiny web application. This web application has a few things here that we'll see in a few seconds. But as an example, we're going to deploy locally a Kubernetes cluster. We'll make use of FluxCTL to actually deploy Flux into a cluster. And of course, we need a GitLab account because this is hosted on GitLab. So let's start by actually getting the cluster up and running. Let me make the font bigger. So this will only create a Kubernetes cluster. There are a lot of options like Minikube or Kind just to get a Kubernetes cluster up and running. So this is just booting up the cluster, and we'll see in a bit what Flux is going to do. So it's just booting up, just a few seconds. So good. So here we are. So let us see if we have nodes. So we have nodes. So the next thing, I already have this exported, so I don't need to do this. So what's going to happen next is that I'm going to bootstrap Flux. So this could be done, for example, in a pipeline that boots up your base infrastructure, and then Flux will take care of actually configuring everything that needs to be done inside the cluster. So what we are going to do is that we are going to point Flux to a GitLab repository. We're telling Flux to look at the master branch. So whatever is reflected on the master branch, Flux will actually sync, and we are giving it a path to the folder where we want Flux to look for those changes. So let's see what's in that path. So here I'm defining some sort of staging cluster. This means that I can point other instances of Flux, or now actually Flux v2 can actually support multiple sources. And we can basically have here a configuration for all of our infrastructure. So what's in here? So here we just have a bunch of facts. So let's see actually what they are. So here I have something called source. And what this means is I'm just telling Flux that there is a Git repository somewhere. I'm giving it a URL. I want Flux to look at the master branch of that repository and pull changes every 30 seconds. So GitLab, it's not cooperating now. Okay, cool. Let's go back. So now I have something called common. So what is common? So common, I'm telling it to look at the Git repository that I've just defined inside that folder and to apply the changes that are in there. So what's in that folder? Let's just take a quick look. So I have something here called deploy, web app, common. So in here I have regular Kubernetes configuration. So configuration of namespace, role-based access control. I have service accounts, so stuff that we are already used to. And of course, the other files look just the same. They will be the deployment, for example, of a backend. Same thing. I'm just saying that look at that Git repository that I've just defined, look inside this folder and wait, for example, for the common to be deployed. So just very quickly, web app, backend, same thing. I'm defining a deployment, I'm defining a service, and the same thing for the front end. So let's make Flux do its thing. So let's bootstrap Flux and let's just see what is going on. So I'm going to bootstrap Flux. So basically, Flux looked at GitLab, found its own configuration, and it will start to boot up. So let's just, the first thing that we're going to do, we're just going to see what Flux is doing. So it usually deploys to something called to a namespace called Flux system. So if we can go here and see, we'll see that it's bootstrapping its own services. Here I could have limited the services that it deploys, but I let it deploy everything. So if I had Helm charts or the Helm chart definitions in that repository, it will also look for it. If I had configured notifications, for example, for Slack, it would have done. So now Flux is actually deploying it. So first thing that we'll do is put Flux to watch for customizations. So it's haven't found it yet. We'll see the logs of the customized controller just to make sure that it's finding whatever it needs to be found. And we're going to watch the applications being deployed. So we're seeing here that Flux is still applying those manifests. And here we go. We're seeing that Flux already found out some of those customizations. It found out that it needs to apply a few things. Here we can see that it's reconciling the state, and it has something called common, something called front end, something called backend. So it found everything, and it started to apply. So it's applying what it's called common. So it's applying the namespace, the service account, whatever is defined in there. It hasn't deployed anything yet in terms of the application, but it will do in a few seconds. So same thing, found out that now it can apply, now that common is applied and it's true that it can apply the backend. So here we're just seeing that the backend, it's already deployed and it's almost ready to go. And in a few seconds, it will actually deploy the front end since there's a dependency from the backend. As soon as this one goes ready, Flux will deploy the other one. So just a few seconds, here we go. This one is up, reconciliation finished, the application is up and running, and the front end it's here. So let's just wait for a few seconds for actually be able to deploy. Just going to do here a port forward to actually for us to see the application. And here we have our application. So it's just an example. You can see that the application is actually exporting metrics. So here's everything without a big fuss, just by defining a set of configurations here. So with 4 files, I actually deployed a whole application. So back to our presentation. So some common questions that usually showed up. So usually people start asking about secrets, and they ask, so now this is all well and good, but now I also need to version my secrets. And of course, there are some options to do that. So one of the options is actually to use something like Vault or Azure Key Vault or AWS KMS and have the applications fetch secrets from there. But that usually implies some changes in the in how the application works. So we would like to actually maintain our workflows. So there are some projects who deal with that. So Bitnami called something called sealed secrets. So the idea is that you encrypt your secrets and they go into Git, very similar to what you would do with Ansible Vault. And then there's an operator that lives inside your Kubernetes cluster that actually looks at those encrypted secrets, has a decryption key, and it will build a secret based on that. There's also SOPs from Mozilla, works in a very similar fashion. And last but not least, there's the Vault agent sidecar injector that lives alongside with your applications. It connects to a Vault server, and it will figure out what are the secrets for that specific application, and will mount a file inside the pod with all those secrets. So there are a few options to actually manage secrets and have them in Git or in something that will be deployed alongside the application. Another common question is GitOps against infrastructure as code. So here the idea is that usually infrastructure as code tools don't manage our whole infrastructure, and in most cases the GitOps it's a philosophy, so it can use infrastructure as code underneath. The drawback is that some tools will use some state in a configuration. It will then use a database to actually manage those states. So there will be weakly linked. And of course, some of those tools don't manage the whole infrastructure. So GitOps is more of a in a broad sense, something that could be used with several tools at hand. And one of the things that you people also usually ask is the fact that we're going from a push model to a pull model. So the idea is that we don't operate something from the outside. We let a cluster to operate from the inside, and that has some added benefits in terms of security. So we don't need to actually expose our cluster to another endpoint or so, or having something pushing stuff in. We actually have the cluster pulling the changes and helping it, letting it to remediate itself. And that's all from my end. I have here a bunch of links that I will make available so that have a general idea. Also, it's pointing to some of the literature that already there is on GitOps. So Weaveworks released a lot of information about it, and there are some actually other cool links that can point you in the direction to actually figure out and make sense if that makes sense to have on your infrastructure.